Today we are going to see the topic factor affecting the focal length of lens. So to understand this topic, first of all, we will see lens maker formula. This formula speaks that reciprocal of focal length 1 by f is equal to refractive index minus 1 by r1 minus 1 by r2, where f is, we know, focal length, n refractive index, and r1 first radii of curvature, r2 second radii of curvature. So these have meaning of this. When we will see the lens maker formula, we will see that the focal length of lens is depend on two factors. First, refractive index of material of lens and its radius of a curvature. So first of all, the first effect, that is effect of refractive index on focal length of lens. So to see the effect of refractive index on focal of length, here it is required to see one formula of refractive index in case of multimedia. Refractive index for air to liquid into refractive index from liquid to glass into refractive index from glass to air is equal to 1. Now see very carefully, when we obtain by this expression, let us give the name of the expression, that is expression number 1, expression number 2. By expression number 2, one may obtain refractive index of glass with respect to liquid is equal to 1 by ANL into ZNA. Furthermore, it can be written as NAZ by NAL, because here we can write 1 by ZNA is equal to ANG. So this formula is applicable here. So finally we may write by using this relation LNG is equal to ANG by ANL. It is equation number 3. Focal length of convex lens in medium air can be written as, on behalf of this formula, the equation 1 can be rectified as 1 by FA focal length in air is equal to, this is air to glass minus 1 by R1 minus 1 by R2. Write as equation number 3. And when you place this convex lens in given liquid, its focal length in given liquid can be written as LNG minus 1 by R1 minus 1 by R2. Equation number 4. Clear it is? Now what we are going to do? We are going to divide equation 3 by equation 4 we have. This is 1 by FA by 1 by FL is equal to, these two terms cancel each other. It can be written as ANG minus 1 by LNG minus 1, or it can be written as FL by FA is equal to ANG minus 1 by LNG minus 1. Right is equation number 5. See what can be seen in this equation 5. Since we know that ANG, refractive index of glass with respect to air, is greater than refractive index of glass with respect to liquid. What does this imply? See in the formula, right hand side of this equation, the right hand side term ANG minus 1 by LNG minus 1 must also be greater than 1. If this right hand side is greater than 1, what does it imply? FL by FA is also greater than 1. Or again this implies that FL is greater than FA. Cross multiply. What does this indicate? What is the conclusion in it? Focal length of convex lens in given liquid is greater than focal length in glass. See, FL is greater than FA. What does it indicate? It means a lens kept in liquid. What does this? Focal length increases. Increases. If focal length increases, it means power of lens decreases. Because you know that power of lens is reciprocal of focal length in meter. So this is the effect of refractive index on focal length of lens. Means when we keep a convex lens in a liquid in place of air, its focal length increases. Time to see the effect of radius of a curvature. In this effect of radius of curvature, the lens maker formula, which is 1 upon f is equal to n minus 1 by r1 minus 1 by r2. Let us see what happened. First of all, we are going to take it in case of bi-convex lens. In bi-convex lens, let us see. First surface of convex lens, second surface of convex lens. First surface, the radii of curvature C1 in this side, C it is R1. So it speaks R1 is positive value, R2 this side, C2, center of curvature. So R2 On the right hand side, this is negative. Now keep both value here in this formula. 1 upon f is equal to n minus 1. 1 by r1 minus r1 has positive value and 1 by minus r2. So it is 1 by f is equal to n minus 1. 1 by r1 plus minus minus plus 1 by r2. See the formula. This implies that, what does it mean? Focal length of convex lens is always positive. When we take the same formula for concave lens, in case of concave lens, let us see. This is concave lens, first side, second side, center of curvature C1, C2, just opposite side to the convex lens. So radii of curvature R1 will be in this side from here to here. R1 is negative, R2 is another side positive, just opposite to the convex lens. In that regard, see the lens maker formula. What does it happen? 1 by f is equal to n minus 1. 1 by r1 minus 1 by, see, r1 is negative and r2 is a positive. It is minus, take common. This is minus n minus 1, 1 by r1 plus 1 by r2. See in this formula, this is the same as previous one, but sign is a negative. What does this indicate? Focal length of concave lens is always negative. So focal length is convex lens is always negative. Now one more important thing can we see in the last one more important result. So one more important result which we are going to discuss other than this is, so let us see what discussed up to here. We discussed that effect of refractive index. It means when a convex lens is kept in a liquid, focal length increases. And when we see in convex lens, focal length is a positive, concave lens negative. Other than all three result, one more important result is obtained in the lens maker formula. What is this? In lens maker formula, see carefully, when the lens is kept where it is kept, denser medium, refractive index more than the refractive index of glass. Refractive index of medium is greater than refractive index of glass. In that condition, this n becomes refractive index of glass with respect to given medium becomes less than 1. In that condition, if it is less than 1, then convex lens behaves like a concave lens, and concave lens behaves like a convex lens, because by this way the sign of the focal length changes. This is for the topic. Thank you and have a nice day.